Last day of review for geometry. This is chapter 10. We're starting with 44. We've got 44 through 50, and that is all. Let me make the screen bigger. And this is it. On the test, I will only ask you for either area or perimeter. I will not ask you for both, but you don't know which one I'm going to ask, so we're going to do both of them, okay, on each problem. So it's kind of like a little bit of double the problems, but whatever. So 44, find the area and perimeter of that figure. What is that thing? What is the shape of that thing? That is a parallelogram. What's the formula for area? Base times height, that's it. And perimeter is just base 1 plus base 2, blah, 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 all of the sides, side 1, side 2, blah, 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 add them all together, right? Okay. Which one is easiest to do for number 44? What? Area is easier, right? Area is base times height. The base is
18.
18, because you add the two together. Height is 16. Those added together is, or multiplied together, sorry.
288.
288, and that is in feet. Oh, 288 feet squared. 288 feet squared. Okay. Now perimeter is a little bit more challenging. If this is 18 on the bottom,
That has to be 18.
that has to be 18 on the top, right? But the two sides don't necessarily have to be 18, right? They could be shorter, longer, whatever. How do we do that? The Pythagorean theorem, right? That's why they give you, instead of the whole bottom being 18, that's why they separate into the 8 and the 10, so that you know that this is 8, this is 16. We can do the Pythagorean theorem with that, right? Okay? So, which side are we trying to find in our Pythagorean theorem?
C.
C. So we're going to leave it as C. 8 squared plus 16 squared, 64 plus 256,
320.
320 equals C squared. And go ahead and give it to me as a decimal. 17.9. 17.9? Okay, 17.9. 17.9. So if I add all of those together, add them all, add them all, add them all. Really, I just add the 18s together. That's 36 plus 17s added together is 34, no, 35.8.
71.8.
71.8 feet. Squared? No, just 71.8 feet. Okay, good? All right, so in that case, area was easier than adding up all the sides because you didn't have those labeled. Okay? 45 is a triangle. And area of a triangle is what? Half the base times the height. Or you can do base times height divided by 2. Either one of those is fine. Perimeter, again, you just add them all, right? What is the base of this triangle? Is it 30, the 8 and the 22 together, or is it just 22? It is just 22. If you say 30, that would be as though this thing was entirely filled in, right? But this piece is missing off the corner of it. So the base is only 22. The height is 16, and you divide that by 2. 22 times 16 divided by 2?
176.
176 feet squared. 176 feet squared. That's the area. Okay, perimeter. I have 2 of the sides. I have 22 and 34, but I don't have this one.
So 16 squared plus 8 squared.
Wait a minute. Wait a minute. Wait a minute. Wait a minute. You said 16 squared plus 8 squared, and that's C squared, right?
Yeah. We got it.
Oh man, we did it. 17.9. So think smarter, not harder. Add all 3 of them together.
Oh.
34 plus 17.9 is something.
73.9.
73.9 feet. Good? All right, so you might have to do the Pythagorean theorem or something of that nature to get these. Okay, 46 is a trapezoid. They want just the area of this guy. Okay, so we've got to remember the formula for area of a trapezoid. For a parallelogram, it's base times height, but I have 2 bases, right? So what do I do with the 2 bases? You like average them together, right? So you take the average of the base and you multiply by the height. Okay, average of the bases multiplied by the height. The bases are 6 and 15. Add those together, divide by 2. That's the average. And I multiply that by 10. Okay, so 6 plus 15 divided by 2, that's what you did, Sable, 10.5. 10.5 times 10, 105 meters squared. The average of the bases times the height. Yeah? Okay. All right, 47. What is that shape? Kite, and we're finding the area of the kite. How do you do that? Half the, they call them diagonals, diagonal 1, diagonal 2. They're kind of like the base and the height. Okay? I see kind of like 4 triangles up here. Triangle, 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 triangle. And so when I see those triangles, the kite kind of reminds me of like 4 triangles, and the area of a triangle is half the base times the height, right? Which is half the base times the height. Does that make sense? There are triangles that show up in your kite, so half base times height is what you're doing for all of them, yeah? Okay, so 1 diagonal is 14, 1 diagonal is 12. It doesn't really matter what order you put them in, okay? If one of them is divisible by 2 and the other one is not, I would encourage you to put that in this spot so that you can easily take half of it, okay? You don't take half of both of them, right? We've talked about that before. You don't distribute the 1/2 through, so it's not like 7 times 6, right? 1/2 of 14 is 7, but then you multiply that by 12, right? You don't distribute the 1/2 through. That is 84, right? 84 millimeters squared. Make sure you label. Good? All right? 48. Find the area of that thing. How do you find the area of a circle? Nope. That's circumference.
Radius pi.
Nope. That's circumference also.
R squared.
Pi r squared. Pi radius squared is the area. Okay, don't use a calculator. Just wait. Don't use the calculator. Don't use the calculator.
100 pi is.
The radius is 10, right? Because the diameter is 20. So 10 squared is 100.
100 pi.
100 times pi. Pi is 3.14159. And you move it times by 100, so move the decimal 2 places. 314.2 meters squared. Okay. Good? Yeah? All right. Next, find the area of the shaded sector. This goes back to and is very similar to what we did on problem number 39. 39, they said, find the length of this arc right here, right? So we did the circumference of the whole thing, because that's what they're asking for, circumference. The circumference of the whole thing was 10 pi, but we only want 100 degrees of it, right? So we multiply by 100 over 360. This one is the same thing, except they're not asking for the crust of the pie. They're asking for the entire shaded in region of that, right? So this has to do with area. Area is pi r squared, and the radius is 10, right? 10 squared times pi. We just did that. 314.2, right? But we only want this little section of it. So what are you going to do? Times 100 over 360. Okay, you can bump off a 0 if you want. So it's just times 10 over 36. Really, that will reduce, but whatever. 87.3 meters squared. These are all areas. Okay, good? All right. Last one, 50. Find the area. Oh, geez. What is that thing? It looks kind of like an arrow. Okay, what are you doing, Holly? Yes, she's saying cut this part off, right? So this is what's called a composite figure. It has 2 of the figures inside of it, so you're going to add those 2 together, right? You're going to find the area of this rectangle, area of that triangle, and then you're going to add them together, right? Okay. So the rectangle over here and the triangle over here, we're going to find the areas of those. To find the area of the rectangle, it's base times height. Okay, what's the base of the rectangle? 12, sure. Height is 5. Okay, you could have switched those around if you said the height is 12 and the base is 5, doesn't matter. That is 60. So the area of the rectangle is 60. Okay, let's find the triangle. The base of the triangle is what? I'm going to write my formula down. Base times height divided by 2. So base is what? 12. What's the height? Yeah, 15. It's not 20, right? From here to here is 5. So from here to here is 15. Yeah? So be careful with that. 12 times 15 divided by 2. Like 90 maybe? 90. Okay? Then add those 2 together. 150 meters squared. Okay? So they might have two shapes kind of stuck together. It's called a composite figure, and you'll just have to separate them and add the areas together. Really, if we couldn't remember the area of a trapezoid and I had everything ready to go, I could separate this into 3 pieces. A triangle here, and a rectangle in the middle, right? That's what I could have done for the trapezoid if I have all the units and everything. Okay? So there's that. Good? Anything else to add? Beautiful. Goodbye, people on the video.
Bye.